Good afternoon, and we are on Limits Day 3 notes. Before we start, I just want to say don't forget to like, subscribe, and hit that bell for notifications. So, we're going to be working on what to do when we can't factor. So, sometimes we get to problems where we just literally can't factor anything, and we need to figure out what to do. So, there's a couple different scenarios when this may happen, one of them being when we have square roots. So, when we have a problem that involves square roots, we want to do something that involves the square root and then direct substitution later. So when direct substitution doesn't work and we get 0 over 0, the indeterminate form, we need to try something else. Our something else that we are going to be trying is called, we need to multiply by the conjugate. Okay, so multiplying by the conjugate is kind of how we deal with square roots. And what it does is it allows it to change what's happening with that square root enough that we can actually do something with it. So the first thing you need to know is what is a conjugate. So a conjugate is when we have two terms, like in our first problem, the square root of x minus 3, and the conjugate is when we change the sign that's in between them. So we change that operation. So our conjugate of our square root of x minus 3 is going to be the square root of x plus 3. So first things first, we need to decide what's happening here. If we were to plug in 9 individually, we get the square root of 9, which is 3, minus 3 is 0. And we have 9 minus 9 is also 0. So if we look at this, we are going to get that indeterminate form 0 over 0. So what we are going to be doing is that multiplication by the conjugate. So I'm going to do some side work because it is a little bit. Okay, so we have the square root of x minus 3 and x minus 9. So we are going to multiply the top and bottom by the exact same thing. It's that special form of 1. So that way we are not changing the value of our fraction. We are just changing what it looks like. So we are going to be multiplying the same thing on top and bottom. The thing that we're going to multiply is the conjugate of the piece that has the square root. So in this problem, we want to take the conjugate of this top part because we want to get rid of this square root. More specifically, we eventually want this bottom piece, x minus 9, which could be in the top if it sometimes. We want this bottom piece, x minus 9, to be the thing that goes away. Because when we plug in 9 here, that's what's causing us to get a 0, specifically in the denominator. So if we can get rid of that, that's going to help us a lot. In order to do this, we use our conjugate. Our conjugate, we take the square root of x, and instead of subtract 3, we are going to add 3. The reason why we can do this is it's kind of like the difference of squares. When you multiply, say, x plus 3 and x minus 3 together, we get x squared minus 9. So this something similar happens here. So we want to multiply these two things together. That means we're going to multiply straight across. When we're doing that, we want to remind ourselves that we are multiplying two binomials together, and that kind of takes up a little bit more than if we weren't. We want to make this easier on ourselves and not harder. So the bottom part of this fraction, we are going to leave alone. We are going to just kind of sit them right next to each other when we are multiplying. The top, on the other hand, we are going to physically multiply out. So I'm going to go ahead and put the bottom over here. So I have x minus 9 times the square root of x plus 3. Okay, so we are going to multiply out the top. So we can kind of use whatever. A lot of you guys might use binomial distribution, which you guys would know as FOIL. You might also use a box. No matter what we do, we need to just make sure that we multiply it all together. So I'm going to try really quick to make a box that we can use. Okay, so we have the square root of x minus 3, the square root of x plus 3. Okay, so I'm going to start with, well, that should be a plus 3. I'm going to start with our easier pieces here. Positive 3 times negative 3 is negative 9. We have positive 3 times the square root of x. That is just 3 square root of x. Negative 3 times the square root of x. Negative 3 square root of x. And then finally, the square root of x times the square root of x. Okay, the square root of x times the square root of x is x. And if you don't believe me, here's why. The square root of x times the square root of x, we're taking something and multiplying it by itself. So we could write it as the square root of x squared. Squares and square roots are things that kind of cancel each other out. They are opposites of each other. So when that happens, whatever we put in is what we're going to get out. Square roots and squared specifically are a little bit tricky. There is one caveat here, but we're not going to have to worry about it right now. So what I'm going to do now is take all of this and put it into my problem. So if I were to add all of these things together, we have x plus 3 square root of x minus 3 square root of x minus 9. Okay. Well, we have a positive 3 square root of x and a negative 3 square root of x. When we combine those with addition or subtraction, they are going to become 0, so they are out. So we are left with x minus 9. So when we multiply these top two things together, we are left with x minus 9. So far I haven't actually canceled anything out. All I've done is multiply out the top, keep the bottom as it is. Well, you may be looking at this and going, hey, we have x minus 9 on top and an x minus 9 on bottom. Well, we can divide these out because that is just a special form of 1. So we're dividing out those two terms, canceling them out, and we are left with a fraction that has the square root of x plus 3 on the bottom. Because when we divide something out, it's really just 1. When we don't have anything left over, we are going to put a 1 in that spot. So generally speaking, if it's in the denominator, it's not a huge deal if we forget it, but if it's in the numerator, it is really a huge deal. So there is one caveat here. This does not equal each other when x is equal to 9. So these are not actually equal to each other unless x is not equal to 9. Because I didn't keep my limit there, I need to make sure that I write that piece of information. So now what we're going to do is we're going to go back to our original limit problem. I'm going to take this and I'm going to say now the limit as x approaches 9 of this new piece that we just got here, 1 over the square root of x plus 3. There is no possible way the top can be 0 or infinity because it's 1, so I know I can use direct substitution and it will give me an answer. So I have 1 divided by the square root of 9 plus 3. The square root of 9 is 3, so 3 plus 3 is 6, so the answer would be 1 over 6. This is one of those things that it just takes some practice and getting used to. So let's look at this next one. This one is a little bit more complicated because there's more in the square root than not in the square root. So what we're going to do is we are going to use our limit notation this time so that way you can see what that would look like. So I am going to go ahead and equals the limit as x approaches 7. Because I already know we're going to need to do the multiplying by the conjugate. So if we were to plug in 7, 7 minus 7, 0. 7 plus 2 gives me 9. Square root of 9 is 3. Minus 3 is 0. So I know for a fact if I were to use direct substitution, this would give me that indeterminate form, so I don't want to use direct substitution yet. So we have our problem, and we need to use multiplying by the conjugate because we have the square root. But this time we're going to multiply by the conjugate of the denominator. So I want to multiply the top and bottom by the same thing. This time we are looking at two terms. So our first term in this is the square root of x plus 2. So I'm going to go ahead and write the square root of x plus 2. Our second term in here is this 3. Originally, they were being subtracted, so now we are going to add them. So the thing I'm going to be multiplying the top and the bottom by is the square root of x plus 2 plus 3. Just like before, we are going to not completely multiply out the top all the way. So I'm not going to multiply these two together. I'm just going to put them in parentheses next to each other like we did here. But I am going to multiply out the bottom all the way. So last time we did the box. This time I'm just going to use distribution. So the top we have x minus 7 times the square root of x plus 2 plus 3. Okay, so we're going to be multiplying these two things out. I have the square root of x plus 2 times the square root of x plus 2. Just like above, we are left with what's on the inside because these are the exact same things being multiplied together. We are going to have just x plus 2. 3 times the square root of x plus 2 and negative 3 times the square root of x plus 2, those are going to cancel each other out. I'm going to write it here just so we see it, but you are going to notice that we are going to immediately cancel them out, but they are still important. And then our final piece, negative 3 times positive 3 to give us negative 9. Okay, so now what we're going to do is simplify what we can. So I have my limit as x approaches 7 of x minus 7 times the square root of x plus 2 plus 3. Okay, so we have x plus 2. Our square roots in the middle are going to go away, so I'm going to go ahead and cross those out. We have x plus 2 minus 9. So x for sure is going to be here. If we have a positive 2 and then we subtract 9, that's going to give us a minus 7. We have an x minus 7 on top and x minus 7 on bottom. So I can go ahead and now divide those out. I can only divide out a polynomial like x minus 7 if I have multiplication between terms or it's the only thing. So because I have multiplication here between our terms and this is the only thing in the denominator, I can go ahead and cancel those out. So this gives me the limit as x approaches 7 of the square root of x plus 2 plus 3. This is all technically over 1. I'm going to write it here, even though we're going to drop it in a second, because it's divided by 1 and we don't really need this anymore. But I know for a fact now I can't have 0 over 0, which means I can use direct substitution. So I have the square root of 7 plus 2, all plus 3. You're going to notice I've dropped my limit notation now, and that's because I am applying that limit now that I am plugging it back in. 7 plus 2 is 9. The square root of 9 is 3, and 3 plus 3 happens to be 6. So we get very similar answers here, but they are pretty different problems. The method that we have to do is that multiplying by the conjugate, which is just like taking that term and switching our sign in between. This works pretty much anytime you have a square root. So it's just kind of like a good tool to have. Multiplying by a conjugate kind of shows up randomly in places.